When bending a U-channel shape, the second bend may hit the ram or die face if dimensions aren't correct. This video shows how to calculate the largest return for a given U-channel width. It helps to understand the bending limits of your press brake and tooling. The description contains links to all press brake content and a detailed thread on supporting material for this video. A helpful drawing and spreadsheets can be found there. When making a U-channel, if the width is too narrow for the side height, the second bend that completes the U-channel will hit the die or ram. Depending on how long the side is beyond what will fit, the part may or may not be ruined. With thin metal, some flex is permissible providing the yield point of the metal isn't exceeded. The example shows a U-channel being bent that is either too narrow for its sides or its sides are simply too long. The second return bend hits the die face, which means an improper bend. Using just 3 measurements, die height, die width, and upper die holder overhang, it is possible to calculate how long a side can be for a given width. Good information to know before bending metal so parts come out as expected. Using 2-inch scrap aluminum, we made a couple of test pieces. The goal here is to verify that the algebra, geometry, and the spreadsheet calculations are as expected. So this first piece is 4 inches wide, and the spreadsheet tells us for that 4-inch width, when we bend the second bend, or the return, that we can only go 2.748 inches, or call it 2.750, before we actually hit the ram. So let's just measure this piece and see how close we got before we go over to the press brake. And we got lucky. You can see that it's 4 inches right there. The sides we're looking for 2.750, so we got 2.756 on this side, and then 2.759 on this side. So this piece pretty good. It'll work for us. This next piece checks things a little differently. We want to remain on the die face with this bend. So the spreadsheet calculator told us that the width is going to be 3.098 and the side is going to be 2.327. And those are the maximum dimensions for this second bend to just stay on the die face. So let's measure that and see how close we got. So we're looking for 3.098. So this one isn't quite as accurate. We're about 7 thousandths wider than what we were looking for, but it's not too bad. And here we're looking for 2.327. So here we got 2.327, pretty much dead nuts on right there, and 2.326. So these pieces are pretty good. So the next thing we've got to check is, let's check to make sure that they're square, and that's pretty good. That's also pretty good. Let's check this one. That's also pretty good. And that's also pretty good. So we've got that, and we can also check the bottom, make sure that it's straight. All right, so that's pretty straight. And this is pretty straight too. The idea being is when this goes into press brake, if this hits the ram and it collides too much, it's going to start to push back here, which is going to cause this to bow. So we can actually check that on the press brake. Let's go over to the press brake and see how these pieces work out. Okay, we got our test pieces here. This one, as mentioned, was 4 inches, so we calculated for a 4-inch width on this U-channel what the maximum side height would be before we started to collide with the upper ram. So we'll go ahead and check that out. Put this piece back in, put a little pressure on it. So you can see it's just touching there, and what we'll do is we'll take a look at the bottom here to see how much it's bowed, and you can see it's a little bit very slightly bowed, so you get away with it with thin metal. But remember that this was a little tiny bit long, so the calculations from the spreadsheet are pretty good. So if you were going to go ahead and make a 4-inch wide U-channel and you wanted to know what your maximum side length is, you could use the spreadsheet to go ahead and calculate that. With thin metal, if it's a little longer, there's some flex, you get away with it. So this is pretty good. This piece here is a little different. There's a disconnect here between the die holder and the actual die face. So when you drop down below that, you're actually on the die face itself. So this piece was calculated to be the dimensions, width and height that just hit up in here, which is a maximum. So we'll put this in here. A little pressure on there, and you can see that it's right up in there. And we go ahead and perform the same calculation, measurement here, to see how far we're bowed out. And very, very slight. Very, very slight there. You see the light coming through there. So the spreadsheet gave us pretty good numbers, and this gives you an idea of what your limits are for a given channel width. And the way this is approached is the width of your channel is known, and then the spreadsheet calculates what your side height can be for those pieces that would fall on the die face or fall up here on the holder or the ram. And also don't forget about the bolts and a little higher up the handle and other obstructions that might be something that you have to take into consideration.